This is the fourth video presentation for the Case Plant course. As you view this video, make notes of important information. Pause, repeat, and resume the video whenever necessary. Structure and Depth Perception 2.1 Understanding Soil Properties. You have just completed Activity 2.1.1 Testing the Feel for Soil. Soil structure refers to the arrangement of those particles in pore spaces. Soil texture provides clues for how well the entire soil profile will function as a system. During this presentation, we will introduce soil structure, types, and grades. We will also discuss how soil structure influences properties such as rooting depth and drainage characteristics. Soil structure is the arrangement of primary soil particles into compound particles or aggregates that are separate from adjoining aggregates. Organic matter has a positive relationship with soil structure grade. In areas of high organic matter production, soils can be found with very well-defined structure. You will explore the influences of organic matter later in this lesson. Soil structure type is the physical shape the soil aggregate or PED displays. The best way to determine type is to break up the clods in your hand with gentle pressure, allowing the clod to break apart into these natural forming shapes. On the slide are two of the 6 types you could encounter in soil, granular and platy. Granular structure is often considered the most desirable for growing plants. Platy does not allow for rapid water penetration or root growth. Blocky and prismatic are 2 common types of structures found in good quality soils. Neither structure is highly advantageous for plant root growth. Neither massive nor single grain are good soils for growing plants. Water will not permeate through a massive soil, and water filters through a single grain soil too fast. Soil structure grade is a determination of soil quality as well. More defined soil PEDs display better characteristics in terms of water movement and holding capacity. Effective depth is essentially how far plant roots will grow into a soil. An alfalfa plant, for example, can have roots growing down to depths of over 20 feet. However, if soil conditions are not ideal, such as a massive layer, root growth will be prohibited. The most common barriers affecting the rooting depth of plants include massive or dense soil structures, poor drainage, abrupt changes between horizons, and gravelly or sandy soil texture. The relationship is somewhat dependent upon water, and in turn, soil water availability is affected by soil properties. Soil color provides clues for quality as well. Color is affected by both water movement, porosity, and organic matter. Later in the lesson, you will explore soil color. Soil horizons with different colors indicate differences in soil properties, such as structure or permeability. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 2.1.2, Adding Structure, you will illustrate soil structure and determine how structure influences soil permeability. This will help you understand that soil permeability is influenced by the texture and structure of soil horizons. Your instructor will provide some soil samples for you to observe and evaluate for structural class.